Okay, so hello students, welcome back. This is Suyash Bajpayee, Suyash Bhaiya here in front of you. So till now we have covered a lot of concept based on kinematics 2D. Okay, let me brief you what we have covered till now. Alright, so students, in kinematics 1D motion, we have covered our concept of position, okay, displacement, distance, clear, speed, velocity, acceleration. We have seen average value of speed, velocity and acceleration, and we have dealt with the instantaneous values. What do you mean by instantaneous values? The velocity or acceleration or speed at a particular instant, right? So if we'll talk about the average values of velocity, okay, it is delta s by delta t, means change in rate of change or displacement, or change in displacement per unit time. But the instantaneous value of velocity is ds by dt, means you have to differentiate your s with respect to time, right? Similarly, if I'll talk about the average value of velocity acceleration, that is change in velocity per unit time. But if we'll talk about the instantaneous value of acceleration, it is dv by dt, means you have to differentiate velocity with respect to time, right? So that's what we have checked. We have solved a lot of numericals based on that, and then we have gone to our next section, that is uniformly accelerated motion. Uniformly accelerated motion means a motion in which acceleration is constant. ओके बच्चों, तो हमने इसमें डील किया काफ़ी सारे प्रॉब्लम से, राइट? और हमने एक एग्जांपल भी देखा फ्रीली फॉलिंग मोशन का. ओके, फ्रीली फॉलिंग मोशन, ओके, फ्रीली फॉलिंग मोशन इज ऑल्सो एग्जांपल ऑफ acceleration of constant. Okay, constant acceleration means uniformly accelerated motion, means your acceleration is goes to minus g. This is also example of free falling body, or you can say this is example of uniformly accelerated motion. So now in this discussion, in this lecture, we'll go with non-uniformly accelerated motion. But means non-uniformly accelerated motion means when acceleration is not constant, velocity is not constant, it may be the function of time, displacement, position or velocity, right? So before going to this concept, I will tell you some basic concept of calculus. Okay, calculus, in which we'll deal with two things. Okay, first is differentiation and the second is integration. It is maths part, but we have to use it in physics. Okay, scientist Newton, right, has defined calculus to use physics problem, okay, or to simplify the physics from problems, right? So we'll see some basic concepts of differentiation and integration in this chapter, clear, in this lecture. So in this lecture, let's come back to the topic, right? So in this lecture, students, I will not tell you what is the physical meaning of this differentiation, right? So differentiation means, let me tell you about something about differentiation. Okay, so differentiation, all right. So students, suppose you have a function, all right, suppose you have a function, suppose you have x, your position, to be as tq, okay, and you have to differentiate this with respect to x, right, with respect to t, time, okay, where x is position and t is time. And suppose you have to differentiate this with respect to time, okay, then it means you have to find dx by dt, okay. This term d by dt means that you have to differentiate with respect to t. What you have to differentiate? You have to differentiate x with respect to t. It is a operator, right? This differentiation is an operator, and I will tell you how to use this operator. Okay, till now you have seen a lot of operator. You know how to plus, how to minus, how to divide, how to multiply. These are the operators, right? Mathematical operators. So there is one more mathematical operator, that is differentiation. Okay, first I will tell you how to use this, clear, how to differentiate the things. In this lecture we'll see how to differentiate a function. Okay, differentiate a function, clear. In the next lecture I will tell you the physical meaning, okay, of your differentiation. Okay, physical meaning of differentiation in the next lecture we'll talk about. All right students, so let me tell you what this d by dt tells you. Okay, so this d by dt means, or this d by dx, anything can be there, right? So means you have to differentiate with respect to time, you have to differentiate with respect to x, you have to differentiate with respect to t, you have to differentiate with respect to x. What you have to differentiate will be here. Okay, you have to differentiate x, or you have to differentiate x, or you have to differentiate some any other function f, right? Clear? So there are some basic formulas of differentiation. Okay, let me tell you this. So this is what I have written already. Okay, so you have to learn these formulas. Okay, so the differentiation, let me tell you this, how it works. Okay, how these formula we have to use. All right, so the differentiation of x to the power n with respect to x, okay, will be equals to n, power will come in the coefficient, right, into x to the power n minus 1, right. Let me give you some examples. Means suppose you have to differentiate x square with respect to x. Okay, then what does it mean? The power 2 into x to the power 2 minus 1. Okay, n minus 1 means 2 minus 1. Just check. Means it will become simply 2x. Suppose we have to differentiate x cube. Okay, check all of you. So it will be simply 3x square. Think by yourself. Okay, suppose if you have to differentiate x to the power minus 1 with respect to x, then it will be what? It will be minus 1 x to the power minus 2. Means differentiation of 1 by x is the what? Minus 1 by x square. Just check. Differentiation of this 1 by x will be minus 1 by x square, right? So yeah, this is just this formula. We have just seen this formula. Okay, this formula 1. All right, so the differentiation of x square is nothing but 2x from here. Okay, the differentiation of minus 1 by x square, x minus 1 by x is equals to minus 1 by x square. Okay, the differentiation of constant from this formula, again any constant. Suppose you have to differentiate this d by dx of k, constant. So constant, you can write it to be as, you can consider this to be as what? X to the power 0 into k, right? So it will be, k will come out of the differentiation constant. Okay, so it is d by dx of x to the power 0. So the differentiation of x to the power 0 is 0. It means the differentiation of any constant differentiation, okay, will always be 0. That's it, right, from this formula again. So let me write down this here. Yeah, so differentiation of constant is 0. Suppose you have to differentiate k times x square. Clear? So constant in multiplication will come out. It is simply k differentiation of x square, right? Means it is it is k times 2x, right? K into 2x. That's it. Just think of it. Okay, I hope this thing is very much clear. So this second formula is also clear. The differentiation of k for constant is equals to 0. All right, now the third formula. Third formula is the differentiation of sine x, okay, is always cos x. Just remember this. Okay, I will tell you some more things based on that. So the differentiation of sine x is simply cos x. The differentiation of cos x is nothing but minus of sine x. Clear? The differentiation of log x is 1 by x. Okay, the differentiation of log x with respect to x, right? So we are differentiation with respect to x, right? So the differentiation of e to the power x, okay, not t, it should be e to the power x. Let me correct it. Yeah, the differentiation of e to the power x will be e to the power x only, right? So these are the formulas. Now the seventh formula is here. Okay, what is that? The differentiation of tan x is sec square x. You have to just learn this, right? Eighth formula, the differentiation of sec x is sec x tan x, okay, into, so the differentiation of cot x is nothing but minus cosec square x. Okay, the differentiation of your cosec x is minus cosec x cot x. Okay, that's it. So these are the formula that you have to learn by heart for differentiation. Now let me tell you some basic examples how to differentiate. Okay, suppose you have a question like this. You have to differentiate following with respect to x. Suppose you have to differentiate your function fx, which is nothing but fx equals to sine x plus 4x cube. You have to differentiate this, right? How will you differentiate? So for differentiation means you have to find df by dx. You have to differentiate with respect to x. Okay, so the differentiation of sine x is cos x. We have to differentiate it 1 by 1. Okay, these are the two terms, right? We have to differentiate these two terms 1 by 1. So differentiation of sine x is cos x. Now differentiation of 4x cube is 4 is constant. It will come out in multiplication, right? Then the differentiation of x cube is nothing but 2x square, right? So it is like this, means x to the power n. So the differentiation of x to the power n is nx n minus 1. So it is, yeah, x cube. Differentiation of x cube is nothing but 3x square. Check. Okay, so it is cos x plus 4 times 3x square. So this is the differentiation. Okay, so now let me increase the toughness level here. Okay students, so now this is your b part. Okay, in b part what we have done, what I have done, this is your fx. Now fx is equal to sine of 4x plus 2 plus 4 times 4x plus 2 cube, right? Means what have been done here, let me erase this and let me solve it for you separately. Okay, all right everyone. Okay, so now this is your function now this time. Okay, and you have to solve it. So what is the difference in this? Means you have not seen any formula to differentiate sine of 4x plus 2. You have the formula of differentiation of sine x. We have the formula of differentiation of sine x. The differentiation of sine x is nothing but what? Differentiation of sine x is cos x. But we don't know the formula here, right? So what we have to do in this case? So students, in this case, we have to consider this to be as x. This complete to be as x, right? Then we have to differentiate this, right? I'm telling you the chain rule now. Okay, the chain rule of differentiation. Note it down. Okay, how to differentiate these kind of things. So the differentiation of sine x is cos of x. What is in place of x? It is 4x plus 2. Now the problem has not ended here. Now you have to multiply by the differentiation of the thing that you have considered to be as x. Means 4x plus 2. आपने 4x plus 2 को x कंसिडर किया. अब आपको उसके डिफरेंशिएशन से मल्टीप्लाई करना पड़ेगा, तब जाके ये इसका कंप्लीट डिफरेंशिएशन आएगा. ऑल राइट, क्लियर स्टूडेंट्स? I hope this thing is very much clear. Now let me do it by permanent here. Yeah. So the differentiation of sine of 4x plus 2 is cos of 4x plus 2, in which you have considered this 4x plus 2 as x. So you have to multiply by the differentiation. You have to multiply by the differentiation of what? 4x plus 2. Okay, everyone, just say. Right. Okay, so what is the differentiation of this 4x plus 2? So we have cos of 4x plus 2 over there, and into the differentiation of 4x is simply 4, and differentiation of 2 is 0. So it is 4, nothing but 4. So the differentiation of this is 4 of cos 4x plus 2. That's it, right? Now the differentiation of this. So again, we don't know the formula of differentiation of 4x plus 2 whole cube, right? So we will consider this to be as x. The differentiation of x cube is 3x square, right? So again, yeah, what you have to do? Plus, yeah, differentiation of this now. Okay, so 4, the differentiation of x cube is what? 3x square, right? In place of x, we have 4x plus 2 square. Now into, you have to multiply with the thing that you have considered to be as x. The differentiation of the thing that you have considered to be as x. That's it, nothing but this is the thing, right, students? So you have here 4, inside bracket you have, yeah, it is to be 3 4x plus 2 square into differentiation of 4x plus 2 is 4 into 4. Okay, means if you see that this is nothing but 4 into 3 into 4, 6, 4 4 16 into 3. All right, just check all of you. 4 3 is a 12 and into 4, yeah, 48. Okay, 4x plus 2 square. That's it, right? So this is the complete differentiation of this function. All right, everyone should check it completely, right? So this is the complete differentiation of this fx, right? Means this is d by dx of f. Okay, check all of you, right? Okay, so now this is your chain rule. Means suppose in place of x you have something else, then just consider it to be x and use the formula that you have learned and multiply with the differentiation of the thing or the function that you have considered to be as x, right? That's it. Again, let me do it for let me give you some more example based on this chain rule. This is called chain rule. Okay students, so let me give you some more example based on this chain rule. So what is that? And here we have this, right? So this is your next example. Okay, so just think about it. C part. Just think about it, everyone. So here you have fx equals to sine square 4x plus 2, or what you can write this to be as sine of 4x plus 2 square, right? Okay, just check, everyone. All right, now this is your function and you have to differentiate this. So 1 minute, yeah, whole square means like this. Okay, so this is your function. Now check, all of you. Okay, so there is a difference in these two concepts, in these two functions. It is sine of 4x plus 2 square. It is angle square, right? Clear? Just check, all of you. Let me use blue color only. Yeah, 4x plus 2 square. It is angle square, square of angle, you can say, right? So these are two different examples, and now you have to differentiate these two. Okay, so let me do the C part first for you. Okay, now this time what you will do, again you have not seen any formula of the differentiation of sine square x, right? But what you have learned, the differentiation of x square. So we'll consider this to be as x. Now the differentiation of x square is 2x. Okay, so we'll use the chain rule again. So it is nothing but 2 of sine differentiation, right? Now I'm writing the differentiation, d by dx of f, right? So d by dx of f, or d by dx, right? D by dx. Check, everyone. Okay, so 2 times sine of 4x plus 2. Now into what you have to multiply with, the differentiation of the thing that you have considered to be as x. What have you have considered as x here? You have considered sine of 4x plus 2 as x. Check, everyone. Is that clear? Very good. So now this time, this 2 sine of 4x plus 2, nothing, into the differentiation of sine 4x plus 2 is, now this time you have to consider this to be as x, so that the differentiation of sine x is cos x, as we have done previously, right? So it is nothing but cos of 4x plus 2. Okay, now you have to differentiate with, now you have to multiply with the differentiation of the thing that you have considered to be as x. Now this time you have considered 4x plus 2 as x. Check, all of you, right? So this time the complete thing is 2 of sine 4x plus 2 as it is, into cos 4x plus 2, and into the differentiation of this 4x plus 2 is nothing but 4. So this is 4. So your answer is 8 sine 4x plus 2, okay, into cos 4x plus 2. That's it. Just think, everyone. Okay, I hope this thing is very much clear to all of you. This is the differentiation of your complete C part, right? So this is your df by dx. Check, all of you, right? Is that clear? So this is your answer over there. Let me keep it in a box for you. All right, so now let me do the fourth part for you. All right, everyone, now just pause the video and do it by yourself, then you will get the thing. Okay, then you will get the concepts. So now you have to differentiate this again. Okay, so what we have to do, we have to find df by d by dx of f, okay, or df by dx. So this time you have to differentiate this thing. How will you do it? Sine of 4x plus 2. What the thing you will consider to be as x now this time, right? So we know the formula of differentiation of sine x. What is that? It is cos x. So now the hint is clear. You will consider this to be x this time, right? So the differentiation is nothing but what? Just check, everyone. Check, all of you. It is simply cos x. What is x? 4x plus 2 square. Now you have to multiply with the differentiation of what? Differentiation of the thing that you have considered to be as x. What you have considered as x here? 4x plus 2, right? Check, everyone. So this time here what you will have? Check, all of you. So it is cos of 4x plus 2 square, right, into differentiation of 4x plus 2 is simply 4. So the answer here is 4 of cos of 4x plus 2 angle square. This is square of angle, right, here. Just check it out. So this is the df by dx here in this case. I hope this chain rule problem is very much clear to all of you. I hope this chain rule problem is very much clear to all of you students, right? Check. Okay, good. Now, so let's move towards two more formulas of differentiation. Okay, so till now we have seen how to these basic formula of differentiation. Till now what we have seen, the basic formulas of this differentiation. Okay, what you have to learn, and using these formulas we have differentiated these sort of functions. Okay, simple functions, and we have seen the chain rule. Now I will tell the two more rules, okay, of differentiation. The second rule is multiplication rule. Okay, multiplication or product rule of differentiation. Means it is very simple, students. Suppose you have a function, okay, means you have to you have function 1 f1x, clear, and function 2 f2x, okay, in multiplication, and you have to differentiate these two functions, right? You have to differentiate these two functions. Then what you will do, you will use product rule. For example, the example of this is, suppose you have x into sine x, okay, and someone told you that you have to differentiate this. Okay, you have to differentiate this function. Okay, means you have to differentiate this. All right, then what you will do, you have to differentiate this, right? So I am telling you a formula. So the differentiation of this is nothing but differentiation of the differentiation of the product of two function is nothing but first function f1x, okay, into differentiation of second function d by dx of f2x, clear? F2, let me write this to be as f1 f2, okay, let it be f2x, yeah, okay. Tool, check, plus second function as it is f2x, check, second function as it is, that is f2x, and to differentiation of d by dx of first function f1. So let me tell you this with the example. Okay, let me do it for this. Okay, so now you have to differentiate this. Okay, how will you differentiate? So first, this is your first function, this is your second function. Okay, so first function as it is x, and differentiation of second function sin x differentiation is cos x, correct, plus second function as it is sin x, okay, and into differentiation of first function which is x, which is 1. So yeah, that's it. So this is the differentiation of this x sin x, the differentiation of x sin, I can write it here directly, the differentiation of x sin x from product rule is nothing but x cos x, okay, plus sin x. That's it. Just check all of you, right? So that's how we use the product rule here. Okay, I hope this thing is very much clear. Now the second rule is, third rule is your division rule. Very simple again. Okay, suppose if you have two functions in division, right, means you have to differentiate d by dx of, suppose f1x divided by f2x. Then the formula of the differentiation of this is very simple. Okay, what you have to do is, you have to just make the square of second function in the denominator, okay, and then your second function f2x, okay, differentiation of first function minus sine first function into differentiation of your second function f2x, okay, check. So this is the formula. Let me tell you with example. Okay, again, so the differentiation of d by dx of sin x by x again. Okay, so this is your, in this case, this is also, you have to use the division formula again. We have to use the division formula again, right? So this is your first this is your first function, and this is your second function. Denominator is second function, right? So second function square in the denominator, right? So x square, then second function x into differentiation of first function, that is the differentiation of sin x is cos x. Okay, minus sign. Now what? First function as it is. Okay, first function as it is means sin x. Okay, then the differentiation of second function, that is x is equals to 1. Okay, that's it. I hope this thing is very much clear, students. Again, let me tell you this again. So the function is in denominator, you have to make the square of that, x square. Then you have to write this function as it is. Differentiation of numerator function, that is sin x, cos x, it will be cos x minus, now this time numerator as it is, and the differentiation of denominator, that is 1, right? I hope this thing is very much clear. So these are some basic formulas, okay, or some basic concepts of your differentiation, right? In this lecture I have covered your differentiation concept. Why? Because we have to use it everywhere in our physics. When we will solve the concept of non-uniformly accelerated motion, then we have to use these sort of things. Okay, so I hope the concept of differentiation have been cleared from here. Alright, in the next lecture we will deal with the concept of integration. Again, let me brief you this once. Okay, so first we have seen some basic formulas of differentiation. Okay, then we have seen 3 rules of differentiation. Our first rule is chain rule. Okay, this is chain rule, right? Suppose in this formula, if the formula we have learned is not fit here, then we have to consider something to be as x, right? Clear? And we have seen 2 more rules, that is very simple rule. Suppose 2 functions are in multiplication, then we have to use multiplication rule. That is what? The first function, that is simply the first function into differentiation of second plus second function into differentiation of first. If 2 functions are in division, then we have to use division rule. What is that? The square of the denominator, then denominator into differentiation of numerator minus numerator into differentiation of denominator. That's it, right? So we have seen some examples. I will give you one more example that you have to do in your homework. We will start from that question in the next lecture. All right, so suppose you have to differentiate. Yeah, I'm giving you an example that will start in the next lecture, E part. Okay, example E. So you have to differentiate with respect to x. What do you have to differentiate? Your fx is simply, yeah, here we have sine square of 4x plus 2 divided by, you will have what you will have, e to the power 4x plus 2. All right, this is your function now, and you have to solve it. Now I will end this session here. You have to solve this numerical completely. Okay, and in the next lecture you will have the solution of this. I hope you will do it by yourself. Okay, you have to find df by dx. You have to find df by dx, or you can say you have to differentiate this f with respect to x. Okay, just do it. Thank you, students. I hope you are doing well. Stay motivated, stay blessed, stay focused, and stay tuned. Thank you.